Today we're doing test 6. We're talking about radians and degrees, all right? So there are two ways to measure angles. We're going to get out of triangles now. We're going to talk about circles. The one that we know about already is degrees, right? We measure things in degrees. It can be 90 degrees, 20 degrees, 180 degrees, whatever, all right? There are 360 degrees in a circle. All right. The other way that we like to talk about angles, and it really helps when we start talking about circles, is by using radians. So these are the two ways of measuring angles, degrees or radians. All right. Radians always include a pi. I wrote that out loud in case you didn't remember that symbol from geometry. And there are 2 pi radians in a circle. If you remember, 2 pi r from geometry was one of our formulas. There it is, 2 pi radians. All right, so here's what we're talking about today. The way to turn degrees into radians is always by multiplying by pi over 180 and then reducing your fraction. You can either do this by hand if you're really good at fractions, or personally, I let Desmos do it. All right, so every single time you see a degree, you're going to multiply it by pi over 180. So 24 pi over 180 is how we're going to convert that. Now, I said I like to use Desmos to do this. So you can't put pi into Desmos, but you can put 24 over 180. 24 over 180. Oh, sorry. Bring back up Desmos here. 24 over 180. And then Desmos will reduce it for you if you click this button right here. So that's 2 over 15. So 24 pi over 180 is really 2 pi over 15 radians. All right, so it's a super simple conversion. So for 56 degrees, we're going to do the same thing. To turn it into radians, it's 56 pi over 180. I let Desmos do all of this for me. So instead of 24 over 180, I want 56 over 180. I left this button clicked so that it automatically reduces it. It's 14 over 45. So that's going to be 14 pi over 45. For 92, I'm going to bring back up Desmos. 92 over 180 is 23 over 45, so that's 23 pi over 45. And then for 360, it's just plain old 2, so 2 pi. All right, so that's how we convert degrees into radians. All right, it's always pi over 180. Now on this next one, these angles, I know it looks like there's a whole bunch, but it's simpler than it looks. These are the ones that are super important. I don't really use 24 degrees very often, but 30 degrees and 45 degrees and all of these are all going to be super important in trig. All right, so everybody pause the video right here, convert all of these degrees into radians and write it underneath there so that we can talk about it. All right, so hopefully all of yours matched up with mine. Now, a couple quick things I do want to talk about. For 30 degrees, what you actually got was 1 pi over 6. I just didn't put my ones in. You don't have to put ones in if you don't want to. But do double check that your answers all match up with mine. These angles are super important. All right. I went to the next page. All right, so before we flip this page over, before we put all those angles on a circle, I do want to talk about the quadrants of a graph. All right, so remember, here's my x-axis and here's my y-axis, and I drew a circle on here. All right, now the first quadrant stands for 4. So this quarter of the graph is called quadrant 1. All right, so this takes us from 0 degrees all the way up to 90 degrees, right, for that right angle. So over there is quadrant 1. Between here and here, so between 90 and 180, this guy is called quadrant 2. Between 180 and 270, that's called quadrant 3. And between 270 and 360, because remember, 0 and 360, a full lap around the circle, you're right back where you started. This is called quadrant 4. Okay, now the reason I want to talk about this is because in a minute we're going to get to graphing things and using the trig values there. So I wanted to talk about where would you find positive x values? Well, x values, positive, is anywhere to the right. And you can see that any time I go to the right, I either wind up in quadrant 1 or 4. So 1 or 4, those are positive x values. Negative x values, so follow this x-axis to the left, that's quadrants 2 and 3. All right, let's do the same for y values. Positive y values says go up along the y-axis, and you can tell that that leads you into quadrants 1 or 2. Negative y values, so go down on the y-axis, you can see that that leads you into quadrants 3 and 4. All right, so now let's get around to actually graphing this. All right, now you need some colored pencils for this, because what I actually want to do is I want to take all the values from this chart right here, and I want to plot them on a graph. I want to say, where does 30 degrees, what quadrant does that in, and what does it look like? All right, and we're also going to label it with pi over 6. All right, so I'm down here in this triangle. Grab one of your colors, and I'm going to use this color for degrees. All right, so 0 degrees starts over here on the right-hand side. Always on the right-hand side is 0. Now, if I start counting up, 30 degrees is a real shallow angle. 45 degrees is half of a 90. 60, and then 90 to get my perfect right angle. All right, and this is kind of the most important, that first quadrant. If I carry on around, I've got 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and then remember, 0 and 360 are exactly the same. Making one full loop around the circle takes you right back where you started. All right, now because degrees and radians are interchangeable, remember we figured out that 30 degrees was pi over 6 radians. I also want to take this and label it. So 30 degrees is the same as pi over 6. 45 degrees is the same as pi over 4. 60 is the same as pi over 3. I'm just looking back at this chart. Oh, pi over 3, sorry. Pi over 2 for 90 degrees. 2 pi over 3. 3 pi over 4. 5 pi over 6. And pi, 1 pi. We've got 7 pi over 6. 5 pi over 4. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6. And then 2 pi. Oh, I forgot to put 0 pi. 0 pi and 2 pi, right? One full loop around the circle. So this is really just to help you out. That chart is super helpful, and that's where I got all these numbers from. But in task 7, whatever comes after this, we're going to start talking about what quadrant is it in. So 5 pi over 6 is in the second quadrant because it's right here, right? So it's really important to have this well labeled. All right, now another thing that we want to talk about that's only going to apply to you if you go on to something like pre-cal. All right, a reference angle is always the distance to the x-axis. Okay, so, and we think of this in degrees because that's what your brain is best at. If it's on the left side, it's the distance to 180 because it's how far away from this angle are we. If it's on the right side, it's how far to 0. All right, so I just want to talk about this real fast. And I'm going to put it out here, all right? This guy, 30 degrees to get to 0, well, that's 30 degrees. 45 degrees to get to 0, that's just 45. 60 degrees to get to 0 is 60. 90 degrees to get to 0 is 90. Surprise, surprise. All right, now when we start talking about here, 120 degrees, notice that I'm no longer very close to 0. I'm actually closer to 180. So instead of asking how far from 0 am I, over here I'm going to start asking how far from 180 am I. So this is subtraction. 120 to 180 is 60 degrees. And you'll notice that these guys match up now. They're both 60 degrees away from the x-axis. 135 minus 180, or I'm sorry, 180 minus 135 turns out to be 45. And you'll notice now that these guys are matching. They're both 45s. 150 to 180, that's 30 degrees. And you'll notice now that these match up as well. All right, this guy is on the x-axis, so I don't need to talk about that. But this 210, notice I'm not very close to 0 anymore. I'm closer to 180, so we're going to measure how far from 180 am I. Well, still subtraction, 210 minus 180 is 30 degrees. And notice that there's three 30-degree angles right now. 225 to 180 is 45 degrees. 240 to 180 is 60 degrees. 270 to 180 is 90 degrees. All right. And now look here. Once I cross over this 90-degree mark, I'm no longer very close to 180. What I'm actually closer to is 360, or 0, right? Technically, 0 would mean going all the way backwards. 360 says count forwards. How far until you hit 360? So from 300 to 360, well, that's 60 away. 315 to 360, that's 45 away. 330 to 360, that's 30 away. And again, this guy is on the x-axis. So something interesting happens here with these reference angles. Notice that all your 30s are all these guys closest to your x-axis. All the 45s are the one in the middle. And all of your 60-degree reference angles, I'm running out of shapes, are the ones furthest. And then your 90 degrees are the ones straight up and down. All right. So down here it says, what do you notice about all of the radians and their reference angles? Look at the denominators in the radians. All of the 30s, all of these guys closest, look at the bottom of all of those radians. They're all over 6. All right. So all of them over 6 are a 30-degree reference angle. I'm going to say reference angle. All right, well, so that pattern has to hold true. So look at all of the 45-degree reference angles. What's all their denominators? Well, the 45s, they're all over 4s. So if it's over 4, it's a 45-degree reference angle. What about all the 60-degree reference angles? They're all over 3. And what about the 90-degree reference angles? There's only 2 of those. One up here and the other one down here. They're both over 2. So if it's over 2, it's a 90-degree reference angle. All right, that bit's going to come back in more tomorrow when we do Unit 7 or Task 7. All right, but the most important thing is to have all of these degrees and radians well labeled and know which quadrant they show up in.